Overamping an electrical panel refers to installing a panel with a higher amperage rating than the incoming feeder can safely supply. The answer to this question is yes, it is generally legal to overamp a main panel when the incoming feeder is of a lower amperage. Here's a detailed explanation. The National Electrical Code, or NEC, sets the standards for safe electrical installations. Local codes typically adopt the NEC, sometimes with local amendments. The purpose of these codes is to protect people and property from electrical hazards. The amperage rating of an electrical panel indicates the maximum current it is designed to handle safely. This rating is determined by the panel's busbars, breakers, and overall construction. The incoming feeder consists of the wires and overcurrent protection, such as the circuit breaker or fuses that supply power to the panel. The feeder's amperage rating indicates the maximum current it can safely carry without overheating or causing damage. When replacing an existing panel, it's essential to ensure the new panel's amperage rating does not exceed the existing feeder's capacity. If the panel has a higher rating than the feeder, it creates a situation where the panel could potentially draw more current than the feeder can handle. This can lead to several problems. Firstly, overheating is a significant concern. If the feeder wires are overloaded, they will generate excessive heat due to increased resistance. This heat can damage the insulation surrounding the wires, potentially leading to short circuits or ground faults. Secondly, fire hazards are also a risk. Overheated wires can ignite nearby combustible materials such as wood framing or insulation, causing a fire. Thirdly, equipment damage is also a possible outcome. Overloading the feeder can damage the panel's components and other electrical equipment connected to the circuit. Fourthly, code violations are a certainty. The electrical codes require that the panel's amperage rating must match or be less than the feeder's capacity. Overamping the panel violates these codes and can result in fines or rejection of the installation by an electrical inspector. To upgrade an electrical panel to a higher amperage, it is necessary to upgrade the incoming feeder as well. This involves replacing the existing feeder wires with larger conductors that can handle the increased current. It also requires upgrading the overcurrent protection device, such as the main breaker, to match the new feeder's capacity. Here's an example. If you have an existing 100 amp panel and want to upgrade to a 200 amp panel, you must also upgrade the incoming feeder to at least 200 amps. This ensures that the feeder can safely supply the increased current demand of the new panel. The appropriate size of the feeder conductors depends on several factors, including the amperage rating of the panel, the type of conductor material, the insulation temperature rating, and the ambient temperature. The NEC provides tables that specify the minimum conductor size required for different amperage ratings and conditions. These tables take into account the conductor's ampacity, which is the maximum current it can carry continuously under specific conditions. For example, NEC Table 310.15 B16 provides ampacity ratings for conductors with different insulation types and sizes. The table lists the allowable ampacities for conductors based on their insulation temperature rating, such as 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius. When selecting the appropriate conductor size, it's essential to consider the termination temperature rating of the equipment to which the conductors will be connected. This rating indicates the maximum temperature that the equipment's terminals can withstand. The conductor's insulation temperature rating must be compatible with the equipment's termination temperature rating. For example, if the equipment is rated for 75 degrees Celsius terminations, you must use conductors with a 75 degrees Celsius or higher insulation temperature rating. It's also important to consider voltage drop when sizing feeder conductors. Voltage drop occurs when the voltage at the load end of the circuit is lower than the voltage at the source end. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To calculate voltage drop, you need to know the circuit's length, the conductor's resistance, and the current flowing through the circuit. There are online voltage drop calculators available that can help with this calculation. In addition to upgrading the feeder conductors and overcurrent protection, It may also be necessary to upgrade the service entrance equipment. This includes the meter socket, the service disconnect, and the grounding system. The service entrance equipment must be rated to handle the increased current capacity of the upgraded panel and feeder. The grounding system is essential for electrical safety. It provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock hazards. The grounding system must be properly sized and installed according to the NEC requirements. It typically includes a grounding electrode, such as a ground rod or a metal water pipe, and a grounding electrode conductor that connects the grounding electrode to the service equipment. It is highly recommended to hire a qualified electrician to perform any electrical work, including panel upgrades and feeder replacements. The electrical work can be dangerous and should only be performed by someone who is trained and experienced. A qualified electrician will be able to assess the existing electrical system, determine the appropriate size of the feeder conductors and overcurrent protection, and ensure that the installation meets all applicable codes and safety standards. When hiring an electrician, it's essential to check their credentials and ensure they are licensed and insured. You can also ask for references from previous customers to get an idea of their quality of work. In Westchester County, New York, electrical work requires a permit from the local building department. The permit process ensures that the work is inspected and meets all applicable codes and regulations. A qualified electrician will be familiar with the permit process and can handle the necessary paperwork. Failing to obtain a permit can result in fines or rejection of the installation. In summary, overamping an electrical panel is illegal and unsafe. It can lead to overheating, fire hazards, equipment damage, and code violations. To upgrade an electrical panel to a higher amperage, it is necessary to upgrade the incoming feeder, service entrance equipment, and grounding system. It is highly recommended to hire a qualified electrician to perform any electrical work and obtain the necessary permits. The following is a breakdown of the key considerations when upgrading an electrical panel and feeder. 1. Assess the existing electrical system to determine the current load and future needs. 2. Calculate the required amperage rating for the new panel based on the load calculation. 3. Select the appropriate size of the feeder conductors based on the amperage rating, conductor material, insulation temperature rating, and ambient temperature. 4. Upgrade the overcurrent protection device, such as the main breaker, to match the new feeder's capacity. 5. Upgrade the service entrance equipment, including the meter socket, service disconnect, and grounding system. 6. Obtain the necessary permits from the local building department. 7. Hire a qualified electrician to perform the work and ensure it meets all applicable codes and safety standards. Ignoring any of these steps could result in a dangerous and illegal installation. Always prioritize safety and ensure that all electrical work is performed by a qualified professional. Doing so not only ensures code compliance but also provides peace of mind knowing your electrical system is safe and reliable. Also remember that this is a general overview, and specific requirements may vary depending on local codes and regulations. Always consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and standards in your area. In addition to the above points, it is important to consider the following when upgrading an electrical panel. Firstly, the location of the panel. The new panel should be installed in a location that is easily accessible and has adequate ventilation. It should also be protected from moisture and physical damage. Secondly, the type of panel. There are two main types of electrical panels: circuit breaker panels and fuse panels. Circuit breaker panels are more common and offer better protection against overcurrents. Fuse panels are older and less reliable, and you may consider replacing a fuse panel with a circuit breaker panel. Thirdly, the number of circuits. The new panel should have enough circuits to accommodate all of the existing and future electrical loads. It is always better to have more circuits than you need, as this will allow you to add new appliances or equipment in the future. Fourthly, the labeling of circuits. All of the circuits in the new panel should be clearly labeled. This will make it easier to identify and troubleshoot problems in the future. Fifthly, the grounding system. The grounding system should be properly installed and connected to the panel. This will help to protect against electrical shock hazards. Finally, the inspection of the installation. The electrical inspector will inspect the installation to ensure that it meets all applicable codes and regulations. The inspector may also require you to make corrections to the installation before it is approved. Upgrading an electrical panel can be a complex and time-consuming task. However, it is an important investment in the safety and reliability of your home. By following the steps outlined above and hiring a qualified electrician, you can ensure that the upgrade is done properly and safely. Additionally, consider the long-term benefits of a properly sized and installed electrical panel. A well-maintained electrical system can increase the value of your property and reduce the risk of electrical fires or other hazards. It can also improve the efficiency of your appliances and equipment, saving you money on your energy bills. Finally, remember that electrical codes and regulations are constantly evolving. It is important to stay up to date on the latest changes and ensure that your electrical system complies with all applicable requirements. This may involve periodic inspections or upgrades to your system.